All right, so now we're just gonna do some more examples. So all right. Let's see, the antiderivative of dx over the square root of 4 minus x squared. Okay. So, Evie, can you go close Daddy's door, please?
Yeah.
All right. So, this one, I think that's it is. That's that right there, arc sine. Let's see. So that's just straight up that. So that is the arc sine of u, which is just x here, over a, so 2, plus c. Okay, this one is kind of it, but u is what? So I'm going to rewrite it as dx over, I mean, since we're going to make it look just like it, but that's not the real reason. You could see that one without doing it, but I want you to see this. This is u, okay? So if you're looking at this one, right? I think that's it, yeah. That's the arctangent, right? Then it's got to just be a plain u squared, not a 9x squared. So that means that I got to do a u substitution, okay? So u is 3x, du is 3 dx. So where'd my pen go? There it is. So I'm going to multiply by 3 and then divide by 3, right? Now that is my du. So now I have 1/3 du over root 2 squared plus u squared. And now that is the arctangent. So then that gives me the, arctangent is 1 over a. So 1 over root 2 arctangent of u, which is 3x over a plus c. Okay? All right, number 3. Let's see. The antiderivative of dx, x root 4x squared minus 9. Okay, if you're looking at your memorization sheets, this looks like arcsecant, but this has to be u squared, and that has to be exactly u, the same, okay? So let's, first of all, just rewrite it. All right, so if you're looking at the arcsecant one, that's a, and then that's u, but that's not u then, right? So before I can even do any kind of u substitution or anything, I have to make these both u. Okay, now they match. See, because the arcsecant has a u on the outside and a u on the inside. Okay, not a half u, which is what I had before. Okay, and then so, but if I put a 2 down on the bottom, I got to put a 2 on the top. Now I can actually do u substitution. So u substitution says that u is 2x, so du is 2 dx. Huh, look at that, I have a 2 dx. So now this is du over u squared minus 3 squared. And that is, now you just follow the arcsecant because now it looks just like it. 1 over a arcsecant of u, which is 2x, and its absolute values, over a, which which is 3, plus c. Okay. All right, one more. The antiderivative of dx over the square root of e to the 2x minus 1. All right, well, let's rewrite that as the integral of dx over the square root of e to the x squared minus 1. Okay, now that's u squared minus 1, which is a squared, right? No. Okay, let's look at our memorization things. I'm looking for u squared minus a squared. I've got a squared minus u squared. That's arc sine, but you can't switch the signs of that. That's plus, that's u squared minus a squared with the square root. Oh yeah, that doesn't even have a square root, but that has a square root, but I need a u out here. Well, let's try the u sub and see what happens. Well, I need a u out here, and I need a e to the x with the dx, right? So if I put an e to the x, now you cannot put things with x's outside of this, but inside is okay. All right, you can never ever like move an x outside or any of that kind of stuff. But if I just put an e to the x here and an e to the x here, that's inside of it, and that's fine because it's inside my integral, my variable of integration. Okay, so now this is du. Okay. Okay, so now that is arcsecant again. So it's 1 over a, which is 1. So then just arcsecant of the absolute value of u, which is e to the x, which e is always positive, so the absolute values are redundant. But if you put them, it's not wrong. And then plus c. Okay? All right. Well, let's see. Oops, wrong one second. Let me find more examples. Okay. Okay, f4 minus x squared dx. Okay, so let's first let u equal 4 minus x squared. I just kind of jumped straight to u substitution. This is also kind of an improper fraction because if you think the square root of x squared, that's an x and an x. But you can't do any division because that square root thing there. I mean, so it really just looks like it's going to be arc sine. See? A squared minus u squared underneath the square root. So I'm pretty sure it's going to be arc sine, but that x on the top is an issue. If it was just a 2 on the top, that'd be fine. Okay, so then du is negative 2x dx. Well, I just said it, right? If it were just the 2, it would work. And then with u substitution, if it was just the x, it would work. Well, then make it that way. You can take your denominator. This is a very common trick, right? We've seen it a couple of times now, where you can take your denominator and just split it into 2 separate integrals. All right, now I'm going to use the u sub for that one, and then this one's just a trig one. So I need a negative 2 and then a negative 1/2. So that gives me du. So now I have negative 1/2 du over the square root of u plus, okay, that right there is, well, just the 2 is out in the front. 2 over, now that's the sine one. Don't know over anything, just 2, right? Arc sine of u, which is x, over 2 plus c. But now don't forget about this one. You still got to do this one. Well, this is negative 1/2 u to the negative 1/2 du, which then you just add, which is 1/2, and divide by 1/2, right? So I get, sorry, I'm kind of running out of room, negative u to the 1/2 plus c. So altogether, I get negative, what was x? What was u? 4 minus x squared, square root, plus 2 arc sine of x over 2 plus c. Okay? Let's see here. All right. One more. Find the area. Hey, Al. Alex. Hang on. You're gonna have to start using your headphones again, but it's super loud, dude. Okay, that was fun. Just couldn't handle it one more second. It was so loud. All right. Find the area of the region bounded by the graph of f of x equals 1 over the square root of 3x minus x squared, the x-axis, and the lines x equals 3/2 and x equals 9/4. Okay. What does the area bounded by the region mean? Okay, under a curve in the x-axis. So area, when you think that, you're going to think integral. Okay. All right. I have no idea what this looks like. But if I plug in 3/2 here, okay, 3/2 would give me 9/2 minus 9/4. 9/2 is bigger than 9/4, so positive. And besides, it's got to always be positive. This is, because it's got the square root, it's always above the x-axis. So the whole thing okay, so the area between this and this, from here to here, I'm going to draw a picture of it for you just so you understand what it looks like. But you don't need to know what it looks like. It's just, I mean, whatever the function looks like, it's like a, it actually kind of looks like a parabola. Okay, but anyway, from 3/2 to 9/4, this is what we want. Okay, but again, you don't need the picture to do this. Okay, because you know it's all above. Now, if part of it was below, then you would need to know where it crosses the x-axis. So you could find the x-intercepts and then switch whenever it's below to negative to give the area, because the area is always positive. Okay? All right. So we're just going to do it. It's just going to be the antiderivative from 3/2 to 9/4. Okay. And then of what? Of 1 over the square root of 3x minus x squared dx. Okay, and that is the area. Now we gotta actually find it. How are we going to do that? Well, it's not any of these, but it's got to be one of those. Well, okay, no. First of all, if I try to do u substitution, then 3x minus x squared gives me a 3 minus 2x, which is not in my numerator, so u sub doesn't work. No. So, all right. So it's got to be an arc one, but I'm going to have to complete the square to get it to be like a perfect square so I can get a u underneath because it's almost a trinomial, okay? So I'm going to let y equal negative x squared plus 3x. Okay, first of all, I don't need to move my c because there isn't one. Then I'm going to divide, so negative y equals x squared minus 3x. Then I'm going to half it. Squared is 9/4. So on this side, I just get negative y plus 9/4. And on this side, I get x minus, and then square root. Now subtract. And then divide by negative. Okay, so now I'm going to get 1 over, and I'm actually going to write the 9/4 first, so it's a minus. So this is 3/2 squared minus x minus 3/2 squared. That's just coincidence here. That does not have to happen. Those don't have to match, right? Because that could be a u substitution now. Now, it's important that I cross that out if I'm doing a free response question because I'm going to make a new u. So I can't have a different u assigned to different things. Okay, so now, and I'm not going to write these things here because I am doing a u substitution, so I'd have to figure those out. Well, just plug them in. So u is what? Well, 3/2. So u1 is 3/2 minus 3/2, which is 0. So that's going to go here. And then u2 is 9/4 minus 3/2, which is 9 minus 6. So 6, 7, 8, 9. So 9, 6, 7, 8, 9. So 3/4. So that's going to go there. Now, you don't have to do that. If you want to go back to your x's in the end and then just evaluate it with 3/2 and 9/4, that's fine. But now I'm just going to leave it with u's when I do it and get the answer with u's. Okay? All right, so then now I get 1. Oops, I lost my dx. 1 over 3/2 squared minus u squared du. Okay? All right, so now that... Ooh, I lost my square root too. Look at me. Okay, there's a square root, the square root. I was like, well, that's none of them. There we go. All right, now that is arc sine. See? No u on the outside, just the constant minus the variable. So I get that is equal to arc sine of u over 3/2. Oh, not plus c. Evaluated from 0 to 3/4. So that's going to be the arc sine of 2/3 times 3/4. See that? 2/3, I just flipped that. And then 3/4 going on top. Minus arc sine of 2/3 times 0. Now you can just box that as your answer, but if you want to know how to evaluate that, just in case it's like a multiple choice question, which I'm not even sure if they're going to be those or not, or I have no idea how the exam's going to work now. So, all right. But anyway, those makes a half minus arc sine of 0.